All right, and welcome to Graphing Linear Equations Part 3. For this part of the lesson, we're going to be looking at deriving the equation of a line from a table of values. So we are going to be looking at a table of values, or looking at a line, and figure out what the equation is that matches the line. So the reverse of what we were doing earlier. All right, so let's take a look at this. We're going to start by looking at a table, and here we have a basic XY function table. So we have X and Y. And we're going to start by graphing the points and joining them with a line. So go ahead on one of your graphs, graph these points, and you're not going to be writing an equation yet. And all I want you to do is graph them and join them with a line. Okay, once you go through and you graph your equation with a line, what you can look for is you can look for other points that lie on the line. So you're going to look for other places where the line intersects two other coordinates. And let's write them down in the table. All right, so I went ahead, I looked at the graph, and I found two other points that I thought could be pretty easy to name. I wanted to pick one that was actually on one of the lines, and then on a point where I could probably pretty closely identify it. So I chose this one right here first, and this one looks like it's at about 3.5 and 7. So I'm going to write that over here, 3.5 and 7. And this one here is about 1.5 and 3. So I'm going to write that here, 1.5 and 3. And so what I was able to do by drawing the line and matching my XY coordinates on the graph is I can identify almost an infinite amount of other points that fall on that exact same line. So if we look at our line like this, we have our point 1 to 2, 2, 4, 3, 6, 4, 8, 5, 10. And we filled in our XY chart. Now what you're going to do is you are going to do what you have been doing since 2nd grade, like Charlie pointed out. You are going to determine what is the rule. So finding what y equals is just like finding the rule. So if we look at this, we can determine what has to happen to x to make it equal y. What has to happen to 2 to make it equal 4. What has to happen to 3 to make it equal 6. And we can see that this number is double that one. So in all the cases, your y equals double the x. Well, we can show that mathematically by saying 2x. So we determine the expression based on that line by filling in the function table, determining what function happened, what operation happened to make x turn into y, and we were able to write an equation, y equals 2x. And that would be the relationship of y and x. All right, so let's take a look at this one. We have different values for x and y in our t-chart, or our function table. We're going to go ahead and graph those on the graph. And then what I want you to do is try to find two other points on that graph and put those coordinates in for the x and y. Okay, so when you see here, you can see I put in 3 other points. I put in this point, and that point. And then I'm going to write my coordinates. So this one is 4, 7. And this one is 6, 9. The next step is to look at the relationship between x and y. How do you get this and get to there? That to there, that to there. What relationship do you see in each of these? You've worked on this in 2nd, 3rd, 4th, 5th grade and gotten more complex. In this one, we can see that 4 is 3 more than 1. 5 is 3 more than 2. 6 is 3 more than 3. So I can write that x equals x plus 3. So whatever x is, I add 3, and that's my y. So I have y equals x plus 3. And so there is, and that's, I should probably rewrite that a little neater, x plus 3. So there is my equation that represents my line. All right, so take a look at this one. I want you to graph the points in the function table. And I want you to choose A, B, C, or D and determine which of those shows the equation for the graph. Okay, what you'll see is the answer is B. Okay? All right, now do this one. Graph this function table on your grid, and then go ahead and solve. All right, check your answer, see if you have the same answer. And let's do one more. Put this one on the grid and then check to see which equation matches your function table. All right, and there's your answer. I'm going to put up 4 more equations. I want you to practice graphing, and we'll check and see how you do. All right, let's start with this one. We have 5x plus y equals 7. Go ahead and fill out the table, make your grid, and then come back and check and see how you did. All right, so you should have went through, figured out what y equals, came up with your coordinates, and yours will not be the same as mine because you used your own. However, your line should fall in the exact same place as mine, so your line will look the same as mine. Okay? Let's look at the next one. Go ahead and solve this one. Do your line and come back and check. All right, this one is going to be a little more complicated, as you can see. I chose my x values, and what I did is, instead of just write my first equation there, because I can see that I'm going to have to be multiplying fractions here and then subtracting fractions there, I'm taking each one and doing it separately as an equation like I've worked. So here, I'm using my variable 1, and I have negative 5/3 times 1, negative 5/3 minus 2 then, because anything times 1 is itself. I converted 2 into 6/3, so I have third as my denominator. Negative 5/3 plus negative 6/3 equals negative 11/3. And when I put that into an improper fraction, I have negative 3 2/3. So I found negative 3 2/3. I graphed my 1 and negative 3 2/3. All right, now I'm going to do negative 1. So when I do negative 1, now if I were you, I would not erase it, but I need the room, so I am going to erase this one. I would have when I do that, I get a positive. I'm going to subtract that once again. Took my 2 over 1 and equaled it to 6/3. So I have 5/3 minus 6/3. If I do 5/3 minus 6/3, I'm going to get a negative 1/3. So here I have negative 1/3. I do a negative 1, negative 1/3. I'm going to get a point about right there. Okay? Once again, you would keep your work. I need the space. Here I am going to do y equals negative 5/3 times 0 minus 2. I know that that is 0, so I know y equals negative 2. I have a 0 and negative 2 right there. And I'm going to do it with my 2. Y equals negative 5/3 times 2 minus 2. 5/3 times 2 would be negative 10/3 minus 2. Once again, I'm going to think of that as 6/3. Negative 16/3 is negative 5 1/3. So as you can see, all of the different skills we have been working on, multiplying fractions, subtracting whole number from fractions, converting whole numbers to fractions, subtracting and adding negative integers, all of that plays a role in what we're doing today. This would be negative 5 1/3. I have 1, 2, 1, 2, 3, 4, 5 1/3. Plot all my points, draw my line through them, and I'm a little bit off. It's hard to get those thirds in there. But your line should look just like that line. All right, let's do another one. Now this one you're probably looking at and going, oh my goodness, I don't know what to do here because there isn't an x. This one actually is quite easy. If you have y equals 3, what you need to know is that no matter where your x is, y has to equal 3. So you'd count back on your line. 3, 3, 3, 3. When you're only given one of your coordinates, and it's the y, it's just one solid line running vertically on the point of 3. Okay? And the same is true for x equals 4. You would find x is always runs horizontal. You would find your point that's at 4, and your line would run there. That is how you graph x equals 4. All right, that is it for graphing linear equations. We'll see you on Monday.